Next up, our second presenter we have from the Department of Earth and Environmental Science. Please welcome to the stage, Caitlin McCavour.
Hi, everyone. As I talk with you for the next few minutes, take a look at the screen and see if you can spot some differences between the forest on the left-hand side and the forest on the right-hand side. There should be a pretty distinct line in which the forest on the left-hand side is significantly less healthy than the forest on the right-hand side. Now think about what a healthy forest means to you. Whether you care about timber production, ecological habitat, or for recreation, a healthy forest is essential both environmentally and economically. Now, unfortunately, in Nova Scotia, many of our forests are suffering and are considered unhealthy, which means they have a low growth rate, decreased productivity, and an increased susceptibility to pests and diseases. This is largely due to lingering impacts from acid rain. Acid rain was an environmental crisis in the 1900s, where increased emissions of sulfur and nitrogen were caused by industrial practices. They were then transported and deposited onto our already acidified forests. This caused two things to happen. First, the depletion of plant essential nutrients such as calcium and magnesium. And second, the increase of mobile aluminum, which is toxic to basically everything you see on that slide except for the helicopter. We thought we solved this problem in the late 1900s when we reduced emissions causing acid rain. However, we have seen little to no improvement in forest health. So if you think of the forest like a human patient, the next step would be to provide it with treatment. And this is in the form of lime. Lime is like a powder which contains both calcium and magnesium and can be deposited onto the forest floor to help restore those essential nutrients lost from the system. You can think of it as like an antacid for the forest. This has been done in many areas of the world, where we've seen significant increases in health, productivity, and growth, and also forest resilience, which may help mitigate climate change impacts. Now, this is yet to be done in Nova Scotia, and that's where my research comes in. We took a helicopter and limed 8 hectares of Nova Scotia's forest at a rate of 10 tons per hectare. This may seem like a lot, but it's really a light dusting over the forest floor. Now, my goal is to study the response of the forest in the short term. To do this, we actually have to look at what's below the surface, at the root of it all, the soil. I'm looking at specific soil chemical properties that may indicate how our forests respond to liming. This will give us a better idea whether liming can be used as an effective forest management practice. So you can really think of my thesis as us trying to figure out whether lime really is the line between an unhealthy and a healthy forest. Thank you.